All right, so this is the video, or the second video of section 8.5. And once again, we're still writing recursive rules. So if you haven't watched the first video, please make sure you do that before you dive into this one, because this one probably won't make much sense if you haven't watched the first video yet. All right, so if you have, this is just a continuation of your notes. So we are on example 4. Okay, and we want to write a recursive rule. We're going to do part A first. For A sub n equals -6 plus 8n. Okay, well, some of you guys can look at this and say, well, this is an arithmetic sequence. And yes, you would be right. Okay, so what I like to do is I like to find the first couple terms, A sub 1, A sub 2, A sub 3. Okay, and so this is just -6 plus 8 times 1. This is -6 plus 8 times 2. This is -6 plus 8 times 3, so on and so forth. So this would equal 8 plus 6 is 14. Oh, sorry, it's a -6. So 8 minus 6 basically is 2. And then 16 minus 6 is 10. And then 24 minus 6 is 18. Okay, so clearly, once again, we can see this is an arithmetic sequence where our common difference is plus 8. Okay, so if you think about this logically, it should make sense. All we're doing is we're taking our term and we're adding 8 to it. Okay, and then our next term would add 8 to the previous term. Okay, so the next one would be 26, and then 34. We'd just keep adding 8. So if you think about that logically, writing a recursive rule should be pretty easy. Okay, we could say A sub n is just equal the previous term, which remember is a to the n minus 1, and all we're doing is adding 8 to it. Okay, now remember when we do recursive, we have to give that our A sub 0 or A sub 1, whatever you want to start with, it doesn't really matter. We have to give our first term because we have to tell them where to start with. So our A sub 0 equals 2. Or you could write A sub 1 equals 2 is fine too. So these together would make my recursive rule. Okay, so using what you learned here, I want you to go ahead, pause this, try to do B on your own. Okay, this should be a geometric one. So try to do B on your own, think of it logically, and then we'll go over it. All right, so once again, this is a recursive. We are going to write a recursive rule for this explicit rule right here. Okay, now, if you want, you can go ahead and do A sub 1, A sub 2, A sub 3. When we have geometric, it's easier to kind of see those without doing that. This is going to be your A1, and this is going to be your R. But if you want to write it out, we can. We'll just go ahead and do that. So -3 times 1 over 2 to the 1 minus 1, or just to the 0 power. This is going to be -3 times 1/2 to the 2 minus 1, which is just the 1 power. And then -3 to the 1/2 to the 3 minus 1, so the 2. Okay, so if you simplify this further, this is just -3 times 1, which is -3. This is -3 halves. This is -3 fourths. Okay, so obviously our common ratio is 1/2. Okay, so with our common ratio of 1/2, so think of it this way, all we're doing is multiplying the previous term by 1/2. Okay, we're multiplying the previous term by 1/2. So we can just say that A sub n is going to equal 1/2 times the previous term, which remember we can designate as A sub n minus 1. And then you always have to write what your first term is, or I like to do 0 term. You can do it 0 or 1, it doesn't really matter, is -3. Okay, so together these would be your final answer. All right, now if I look at example 5, now we're going from recursive to explicit. Okay, so right now we're given the recursive rule. We're saying that every term is the previous term minus 2. Okay, so you should be able to identify that that is an arithmetic sequence where our common difference is -2. Okay, and it tells us that our A1 is -5. Okay, so remember way back, and I think it was section 2, where we could always write an explicit rule for an arithmetic sequence as a sub n equals a sub 1 plus parentheses n minus 1 times d. Okay, well that hasn't changed here, guys. We're still going to do the same thing. So a sub n equals, my a1 is -5 plus n minus 1 in parentheses times my common difference is -2. Okay, now I just want to clean this up. So a sub n equals -5 minus 2n plus 2. So a sub n equals -2n minus 3. Okay, that would be our final answer. And since we're not writing a recursive rule, then we do not need a sub 1 as whatever. Okay, so this would just be your final answer. All right, I want you to try B on your own. Now we're going to geometric. Okay, so remember geometric sequence is a sub 1 r to the n minus 1. Okay, that's the rule to write geometric. So try it and then we'll go over it. All right, so hopefully you tried to work through this one out. All right, so we can see in this recursive rule, which is right here, that we're multiplying the previous term times 2. Okay, so that should tell us that it's a geometric sequence, and our common ratio is 2. Okay, and then we're given our first term is 10. Okay, so I can write it in this rule. So a sub n equals a1 times my r, which is 2 to the n minus 1 power. And guys, that is all you have to do then. Okay, don't make these harder than they are. All right, guys, if you would like more practice, or if you think you need more practice, or you're still confused or whatever, go through and do these monitoring progresses on your own. And then I will flash up the correct answer and how I got to them. So go ahead and pause this and do this if you want more practice, and then we'll go over. All right, so if you worked through these, this is what you should have gotten. So here's 1 and 2. And then here's 3 and 4. All right, so let's look at example 6, this word problem here. It says a lake initially contains 5,200 fish. Okay, so we're starting with 5,200 fish. Each year the population declines 30% due to fishing and other causes. So the lake then is restocked with 400 fish. Okay, so we start with 5,200. We lose 30% of those 5,200, and then we add back 400. Okay, so we want to write a recursive rule for a sub n, which tells us how many fish we have when we start the nth year. All right, well, 5,200, this is our a1. Okay, so let's think about this here. So if we're losing 30%, think of this as like in terms of decay growth of exponential growth and exponential decay. That means we're keeping 70%. So we want 1 minus 0.3, which is 0.7. Okay, so we want, basically, we decline 30%, so we keep 70% of our fish. Okay, and then we add 400. So I could write and we want a recursive rule. A sub n equals, we're going to multiply our original number. Okay, we're going to multiply that by 0.7. Okay, so this would be, we have 70% of what we started with, but then we're going to add 400 back. Okay, now remember when we do recursive, we always have to give our starting point. So I could say the start of year 1 is 5,200 fish. Okay, so together this would make my recursive rule. All right, so let's look at part B of this problem. Okay, so it says find the number of fish at the start of the 5th year. Okay, well at the start of the 1st year, we know we have 5,200 fish. Okay, at the start of the 2nd year, we're going to start using this formula. Okay, so the start of the 2nd year, we use this formula here. A sub n minus 1 means we're going to use the previous term. and then we're going to multiply it by 0.7 because we want 70% of that. We're going to lose 30%, keep 70%, and then we're going to add back 400. Okay, so when I put that into my calculator, I get 4040. Okay, now at the start of the third year, okay, it's going to equal my A sub n minus 1, so my previous term, so 4040. Once again, I'm keeping 70% of it, but then I'm adding back 400. Okay, and that gives me 3228. Okay, at the beginning of my fourth year, I'm going to have my A sub n minus 1, so my previous term, and I only want 70% of that because the others die off, and then I'm going to add back 400, and that gives me 2659.6. Now I know I can't have 0.6 of a fish, but that's not my final answer, so I'm just going to keep it and go. Okay, and then the start of my fifth year, this is what I want. I'm going to have my previous year, so 2659.6. I'm going to keep 70% of that, but then I'm going to add back 400. Okay, and when I do that, I get roughly 2261.72. So I can say, obviously these numbers aren't 100% exact. I can say at the start of year 5, I have roughly 2262 fish approximately. All right, now C might surprise you a little bit, but really if you think about it, it shouldn't. I'm going to grab my calculator and we're going to do this on the calculator. All right, guys, so now that I have my calculator up, we're just going to put this one into our calculator, and I'm going to show you how to do that. All right, so the first year we have 5,200 fish, and once again, we're going to keep 70%, so we're going to multiply by 0.7, and then we're going to add 400. Okay, now on my next line, rather than typing this 400 or 4,040 in, I'm going to hit my second A and S. Okay, so I hit second and then this button right here in red. And all that does, anytime I put A and S, that means answer. That takes the answer from the line above. Okay, so this means I'm going to take 440 since it's from the line above. I'm going to multiply it by 0.7, and then I'm going to add 400. Okay, and I'm going to hit enter. Okay, so this is just the same as what we had on part B. Now, because this is in here has the answer, it's programmed to go to the line above, I can just hit enter, 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 enter. Okay, it gives me the same equation, but it's going to take the answer from the line above. So if I keep hitting this several times, yes, it's decreasing, but eventually we get to where it is roughly the same. Okay, so notice we're not going anywhere. We're stuck. We're stabilizing at about 1,333. So what ends up happening is that the 30% that's disappearing is being replaced by that 400. So 400 is about 30%. So we're losing, but then we're adding roughly the same amount. So the answer to part C is that we would stabilize at about 1,333 fish, and it would stay roughly around there.